Welcome to Maths with Jade. In this video tutorial, I will be teaching you the quadratic formula, which is this absurd looking thing. Let's first take a look at what a quadratic equation is. Well, the most generic form of it would be ax squared plus bx plus c equals 0, where a, b and c are numerical values. Here are some examples. Sometimes you may find the equation rearranged or even factorized. But what makes it a quadratic equation is the x squared term being the highest power of x. If you ever end up with a quadratic equation, you want to ask yourself, what is x? And I would really hate to upset anybody so early on in a video, but for quadratic equations, x could be two things, and sometimes there are even no solutions for x. There are three ways to find the values of x. We can solve by factorizing, solve by completing the square, and solve by the quadratic formula. In today's video, we will be looking at how to solve with the quadratic formula. If we have this equation, ax squared plus bx plus c equals 0, we can substitute these values a, b, and c into our quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac all over 2a to find our values of x. If you wish to see how to prove the quadratic formula, I made a video on this recently and a link is in the description. You need to learn this quadratic formula off by heart and remember it forever. I know what you're thinking, when will I ever need this? But you don't know what the future has in store, and one day the fate of the world might rest on you solving a quadratic equation. And if you ever find yourself in this situation, you're going to feel very silly for not taking my advice. So take some time now to learn the quadratic formula. Pause the video now. Okay, now grab a pen and paper and see if you can recite the quadratic formula before I do. And here's what you should have got. If you didn't get that, repeat this exercise until you do. Let's look at an example of this. So solve the following. We have x squared minus 2x minus 5 is equal to 0. If we just compare that with our generic quadratic equation, we can check the right-hand side is 0, great. So now I'm going to identify the values of a, b and c. A is how many x squareds we have, in this case a is equal to 1. B is how many x's we have, in this case it's minus 2, and c is our constant on its own, in this case minus 5. I have assigned A, B and C a colour, and now I'm going to write out the quadratic formula using those colours for you to see more clearly what we substitute where. And now what I'm going to do is open a bracket everywhere that I see A, B or C. And then inside those brackets, I'm going to write out the specific value we have from our quadratic for A, B and C. The reasons for the brackets is so you can see clearly what the sign is of each of the values, because you'll find when doing this that a lot of positives turn to negatives and a lot of negatives turn to positives because a minus and a minus multiply together to make a positive. So let's simplify this. We have minus negative 2, which becomes positive 2, plus or minus the square root of negative 2 squared. That will become positive 4. And then minus 4 times 1 times minus 5. And that's all over 2 times 1. We can simplify again by carrying out those multiplications. So we get x is equal to 2 plus or minus the square root of 4 minus minus 20 all over 2. Well, I know 4 minus minus 20 will become positive 24, so I can simplify again. Now at this point, I want to have a look at the number inside the square root because it tells us one of three things. If it is bigger than 0, there are two solutions for x. If it is equal to 0, then there is one solution for x, and if it is smaller than 0, there are no solutions for x. We have a number bigger than 0, so we know we have two solutions for x. So x could equal 2 plus the square root of 24 over 2, or x could equal 2 minus the square root of 24 over 2. If you have some good surd knowledge, you might want to find an exact value for these two solutions. However, I will be using a calculator and rounding to three significant figures. So I get x is equal to 3.45 or x is equal to negative 1.45. So my second example is not going to equal 0. So we need to make it equal to 0. So I'm just going to add 1 to both sides to make the right-hand side equal to 0. You could in fact make the left-hand side equal to 0, but in this case it would make no sense to do that. So we establish what is A, B and C. Well, A is 9, B is 6 and C is 1. So now I'm going to go through this a bit quicker this time. Here's my quadratic formula and I'm just going to substitute in my values into the brackets as I go for A, B and C. And now I can simplify. So x is equal to minus 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 9 times 1, all over 2 times 9. I can simplify further because I know 4 times 9 times 1 is 36 and 2 times 9 is 18. Now, this gives me 0 under our square root, which means there is only one solution for x. And that solution is negative 6 over 18, which does simplify to negative 1/3, but I will leave my answer, as always, to three significant figures, negative 0.333. Now it's time for a different kind of example. The length of a carpet is 1 meter longer than its width. Its area is 10 meters squared. Find the length and width of the carpet. So let's say the width of the carpet is x. Well, the length is 1 meter more than that, so that's going to be x plus 1. We know that the area of a rectangle is the width times the length, so x times x plus 1. And that's equal to 10. Now we can just multiply it out and then bring the 10 to the other side, so our final quadratic will be x squared plus x minus 10 equals 0. We have 1x squared, so a is equal to 1. We have 1x, which means b is equal to 1, and our constant on its own is minus 10, so c is equal to minus 10. Here's the quadratic formula again, and I'm going to go through this even quicker this time and skip the bracket stage. So I get minus 1 plus or minus the square root of 1 squared, which is just 1, minus 4 times a times c. And that's all over 2 times a. We know that 4 times 1 times minus 10 is minus 40, so we can simplify again to this. And we know that 1 minus minus 40 is 41. And now we're ready to check to see how many solutions there are. And for x, there are 2 solutions because we have 41 under the square root. X is therefore equal to minus 1 plus root 41 over 2, or x is equal to minus 1 minus root 41 over 2. Now you can use your surds knowledge, or you can use a calculator and round to 3 significant figures. And I get x is equal to 2.70 meters, or x is equal to minus 3.70 meters. Now you have to use a bit of common sense here because a length obviously cannot be negative. So we can just cross that solution out. It is invalid in this scenario. So to answer our initial question, the width x is equal to 2.7 meters and the length x plus 1 is equal to 3.7 meters. Now it's your turn, so either find the solutions to the following quadratic equations or answer the questions. Pause the video now. So the first 5 questions are pretty straightforward. Here are your solutions. For question 6, you need to know that the area of a trapezium is the 2 parallel sides plus together times by the height divided by 2, and that is equal to 80. And then you can simplify by expanding out the brackets. And that divided by 2 gives 3x squared plus 15x, and then minus the 80 to the other side and solve that quadratic. One of the solutions is negative, so you get one valid solution, and that is 3.24. For question number 7, split the shape into 2. You can label it A and B if you want to, and then plus A and B together and make it equal to 25. That will give you this expression. Multiply that expression out and simplify, and you end up with a quadratic once you've moved the 25 to the other side. Solve that quadratic, get rid of the negative solution, and you get x is equal to 1.5, and then use that to find the missing sides. For question number 8, you need to use Pythagoras' theorem. So a squared plus b squared equals c squared. Substitute in what you have on this triangle for a, b, and c. And then you need to do a bit of a long job, and that's expand all of that, simplify it, move it all over to one side, and then solve for that quadratic. Again, one of the lengths is negative, so you just want to take the positive length and then use that to find the lengths of each side of the triangle. Thank you for watching. You have made it to the end of the quadratic formula, so well done. This has been Maths with Jade, and if you found this video useful, please do hit the like button, subscribe to my channel for more content, share this video, and all comments below are very much welcome.